called Fishbait, and we have created a system in which we are tracking a fish through the water. And how this is done is through dead reckoning. And how dead reckoning works is you collect a GPS signal about where you let the fish go initially, and over time you collect data about where this fish has gone, and the system will collect information, depth, temperature, speed, and direction. And every 10 seconds we'll collect the circuitry will collect that information, and after we get the system back, then we are able to analyze the data and find out where this fish has gone and what it has done.
Okay, so this is the hardware for our Fishbait project, and we're going to go through each of the modules that we used for it. This is our microprocessor. It is the LPC Espresso. 32-bit Cortex M0 is what's used for that, clocked at 48 megahertz. And we use that mostly for the timer to fire our 10-second interrupt to take our readings, and it handles all the SPI and the I2C communication to each of the other chips. We use this chip mostly because it had really low power ratings when we put it into low power modes, which it is most of the time since it only has to take a reading once every 10 seconds. This over here is the accelerometer and gyro board, both of which have 3-axis readings for the accelerometer, the gyroscope, and the magnetometer. And this is really what allows us to track the fish. The magnetometer gives us the fish's heading, the accelerometer gives us its speed, and the gyroscope gives us kind of the turns that it makes and the pitch that it uses. It has a I2C interface that we wrote a driver for in order to make that communication possible. This over here is the barometer and temperature sensor that tells us the depth of the fish, and just kind of an idea of the water temperature, as any effect that could have in tracking. This is the last piece, and it's the memory where we store each of the data and what we would eventually read out each part. Both of those are SPI interfaces and are controlled by the SPI controllers built into the LPC Espresso.
Alright, we're going to do a demo of Fishbait. So here is main, and walk you through here. We initialize our different components, initialize the timer, put things to sleep, get the priority and the interrupt all squared away, and then start the timer, and then that is all that we're doing in main. If we look up here into our handler, you'll see that we're toggling an LED, and then we wake up the sensors and the memory. We get data, and then as we get data, we're putting each sensor to sleep, and then we write out to memory. So let's go ahead and get this put down on the board. There we are. We're debugging. Now when I hit play, we're going to have a 10-second pause, because that's what we want our tag to do, is sleep for 10 seconds, and then it wakes up and takes a reading and goes back to sleep. So we'll go ahead and hit play and then wait for the breakpoint. There we go. And we can look at the data. You can see we're here in the handler. And let's go ahead and see the data that we have. Here's the temperature. The balmy 75 degrees, and the pressure is 85.4 kPa, whatever that means. And then we have our ADC data for our accelerometer, our gyro, and our magnetometer. And now let's get ready to capture us writing it to memory. We'll go ahead and hit start. We're waiting for it to trigger. We'll go ahead and hit play. We come back and let's go ahead and look here. So what we have is we have a 06 opcode, and that tells it to be write enabled. And we have a 02 opcode that tells it we're going to write, and then our address we're writing to is all zeros. And then here's our float, these 4 bytes. That's for either pressure or temperature. And then this one is another float for temperature or pressure. I'm not sure which order they go in. And then after that we have shorts that we're writing out. That's the ADC data. And you can see that the enable line is a low, clear until we're done sending the last byte, and then it toggles back high. And that concludes the demo of Fishbait.